Okay, in this video we're going to look at uncertainty, because uncertainty is one of those things that a lot of people really struggle with in terms of the practicals, and since the practical endorsement has come in, we've got a lot of calculations to do in practical work to prepare you for the kind of questions that occur in the test, and you need the data in order to do those calculations to understand uncertainty. So you need plenty of practice on them. So it's good to watch this video as early as possible before doing your first practical endorsement practical, to see if you can throw some uncertainty calculations in there. Have a go. I'm going to show you over the next video or so how to do those. So first basic form of uncertainty is uncertainty in a measurement. Now, what is uncertainty? Uncertainty is how much you're like, okay, well, it could be within that kind of idea of range. So you normally see an uncertainty written like something as a value that you've got, so let's say 34 of something, and it'd be plus or minus. In this case, we'll go for 2. And this value here is the uncertainty. That is basically saying that this value is what x is plus or minus 2. That's saying that the value of x could be 32, or it could be 36, or anything in between. Okay, so it can be anything in between. So that's the basic understanding of uncertainty. It just gives a range of what the measurements could be based on what we've observed in the practical that we've done. So if we then look at a real version, now probably one of the first things you will have used to measure, and one of the things you will use to measure over and over again, is a ruler. So a ruler is pretty easy. We can do some uncertainty calculations around this. So if I make a measurement of uncertainty along here, so let's say I'm going to measure 17.5 centimeters. 17.5 centimeters. So my distance equals 17.5 centimeters. So how do I work out the uncertainty in that measurement? Well, your uncertainty in your measurement is the smallest division. Okay, I'll say that again. It's the smallest division. What's the smallest division on a ruler? It's a millimeter. A millimeter in centimeters, okay, is a 0.1 of a centimeter. So we've got plus or minus 0.1 centimeters. So we're saying, because that is the finest division, it can be anything between that. It could be anything from 17.6 to 17.4. Okay, it could be anything in between that, because that's how our uncertainty works. And if you got a more accurate distance measure, you would observe actually that distance, if I was to measure that was 17.5, whatever measure that was 17.5, might be 17.52 or 17.53. We don't know, because we haven't got a small enough measure. So that's a basic understanding of uncertainty and around a measurement. Now the next bit is how we turn that into a percentage, because oftentimes we need to be able to use them as percentages because we want to combine them with something else. Okay? You do need to be able to do percentage calculations. On the whole, you do need to be able to understand the rearrangement of them, really more than anything else. It's very, very important. So your basic percentage calculation looks something like this. It's the smallest division divided by the value times by 100. Okay? Now I put that times 100 off to the side because when you times it by 100, you're moving it from a decimal into a percentage. Okay? And you might want to be able to convert between the two by timesing or dividing as need be. So smallest division divided by the value. So in this case, we've got 0.1 divided by 17.5. We're going to times that by 100. 0.1 divided by 17.5. So that's 0.57%. Okay, I've done some rounding up there, but 0.57%. So that would be my percentage uncertainty around this value. Okay, around this value. Okay, in the next bit, what we're going to look at is a different way of looking at uncertainty, and that is through when you've got more than one value that contributes towards, in this case, a mean. Now I've got some pre-prepared data here that I'm going to use just to show you it, because I've tried and tested it, and it's going to lead us quite nicely where we want to go. So, say for example, we've taken 3 readings, 1, 2, 3. And first set of readings is 3, 3.5 and 4. Next one is 6, 6.7 and 5.9. Next ones are 9, 9.2, 8.6. Nice point to make here actually about your practical endorsement. There's something wrong with this data. Well done if you spotted it. I've got an incorrect amount of precision in my values, so we should be looking to make sure my precision, which is my decimal places, remains constant. Okay, so my precision in this case is decimal places. And we're looking to find an average of these. You should be able to find averages. You should be able to do that from GCSE. If you work out the averages, we get 3.5, 6.2, and 8.9. By average, I mean mean. So you add them all up, divide by the number of values that's there. Okay, so all well and good. How would I work out percentage uncertainty for these values there? Well, if you've got a range of values that contribute towards a mean, we need to use and incorporate all those values into the calculation. The calculation as it stands should be this. So as before, we had the smallest division divided by the value. This time we have half the range divided by the mean times 100. So similar style of working out percentage uncertainty here. What we're looking at is we've got a value that represents between what it could be and the mean there, the value itself. So in each of these cases, if we look very carefully at what it is, so we've got the smallest and lowest value is 3 and 4, so we've got a range of 1. Okay. Half the range is 0.5. 0.5 divided by 3.5 times by 100. If you put that into your calculator, you should get 14.3%. Next, please note as well, I'm using 1 decimal place for the percentage because I had 1 decimal place everywhere else. We stick to the precision as best we can of those values. So, next one, if we work it out, it should be 6.5%. Next one should be 3.4%. So that's what you should be able to. You should be able to work those out and prove those values there, no problem. Now I'm actually going to leave these up, but I'm going to rub out. I'm just going to write down what the ranges are first because I'm going to need those. So the range for this one was the plus minus value would be 0.5 plus minus value. So we've got 0.8 to 0.4 plus minus 0.4, and that one will be plus or minus. So that's 6, 8, so 0.8. So 4, 5, 6, 0.6. Plus or minus 0.6. Look at the right values, aren't they? Yes, that's right. Okay, so plus or minus 0.6. So I've got the ranges on there, and I'm going to need those for the next bit. At any point, if you need to rewind the video just to look at the values and see what I've done there, then please bear that in mind there. Okay, so now normally when we get a set of data like this, we would look to put it on a graph, wouldn't we? So let's draw our graph. And we have what we changed at the bottom here, so I've just got 3 values. Call that 1, 2, and 3. So we've got 1, 2, 3, 1, 2, 3. And then we need a scale on the left-hand side that goes up to 10. So we've got 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10. Okay, so this bar represents these values that we're going to go for here. So we can actually plot these now really nicely. So the first one is 3.5, so it's about there. 2 is 6.2. 3 is 8.9. Yeah, that's about right. So what we end up with here is we got a nice straight line. Now you would probably normally at GCSE draw a straight line through those. You might draw it from the origin. This doesn't look like it's going to go through the origin, so I won't do that. But we've got some uncertainty. So what am I going to do with that uncertainty? Well, yeah, I've worked out a percentage, but that's only going to be useful when we look at combining uncertainties later on, especially in gradients and things like that. We can do some more advanced work on this in lesson if need be. So we've got, however, a range here, or an uncertainty. So we can actually plot an uncertainty around my average. So we've got plus or minus 0.5, plus or minus 0.4, plus or minus 0.6. So what we're ending up with here is, we can draw some error bars. So the one at the top is going to be the biggest one. Apologies, that was 0.3, wasn't it? So, sorry, the one at the bottom is going to be the smallest one. So, small, bigger, even bigger. Now I might have exasperated those error bars, but I'm just going to use them to prove a point here in a second. Okay, so normally we draw our line of best fit through that, and I'm going to do it as best I can. There we go, nice straight line of best fit through the points, and we'll be cutting as many points as we can, or having an even split on both sides. Yes, that should be a straight line. Right, so where do I go from here? Well, I want to work out, there's more uncertainty that we can calculate here. Because we've drawn a line and say we work out a gradient on that line, then all well and good, we'll get a value for that gradient and we'd say, well, whatever the gradient represented is what it was, and that value was what it is. However, we're a bit jumping the gun there because clearly there's uncertainty in that final measurement that we haven't taken into account. So, what we'll look to do is draw ourselves a second gradient line that represents a worst line of best fit. Now, a worst line of best fit would look something like this. No, it wouldn't look something like that. Let's try that again. Yeah, it might look something like that. And we try to take as exaggerated gradient as possible. And so now we've got two potential gradients. Two potential gradients means we could then calculate the two gradients, see what they are, and then use the same method as the multiple values, half the range divided by the mean, in this case it'd be 2 values of gradient, to find the uncertainty in the gradient. So you take a mean of the two gradients, then you work out the uncertainty using the secondary method I've just shown you. So that is a very, very helpful process, especially since we're going to be drawing a lot of graphs in A-level physics. Right, so once you've done that, you're pretty much good to go. And you've got a best line of best fit, you've got a worst line of best fit, and the difference between that represents essentially a plus or minus value. Okay? Right, moving on. The last part of uncertainty you need to be aware of is what happens when we combine uncertainties. Now I'm going to do that in the next video because, well, I'm going to split it up a little bit. It gives you time to assimilate what you've just learned. So in the next video we're going to look at combining uncertainties, and I've got some more data for you to just have a play with. And do come with any questions about uncertainty. If you want to come see me outside of lessons or post a message on here, brilliant, please do. Uncertainty is something you've got to get your head around. There are multiple choice questions on it, there are full questions on it, so it's something that is really, really should hit home, that you need to spend some time with. Okay, bye.